Let's see. Oh. How about this? All right. Okay. I'm going to talk about Hawk and HA, which is high availability clustering. And it's going to be a pretty quick introduction to clustering if you haven't done it before. But I'm going to try to get it to make sense so I can show you some of the interesting stuff that you can do with Hawk. So, first of all, my name is Kristoffer Grönlund. I work at SUSE on the HA team. I primarily develop CRM shell, but I also maintain a bunch of other packages. And I'm going to start developing Hawk more going forward. So yeah, and pretty much, yeah, I think everything I do for SUSE is online, open source, and most of it you can find on GitHub. So that's my handle. So I'm going to start by introducing HA very quickly. It's going to be abbreviated. Then I'm going to talk about Hawk, some of the features, what it is, what it does, how you can use it. Then I'm going to show the History Explorer feature in particular in a little bit more depth, and that's it. So, yeah, high availability is, yeah, it's like that. High availability is basically trying to take something that is not highly available and make it highly available. So you have an application like a web server that may crash, and you want to keep it so that the user of the application never notices that the server may have crashed or that the software may have crashed and so on. So using special software, you want to be able to handle hardware failures, software failures, any kind of other things. One of the coolest things I've heard someone do is they hooked up monitoring systems to the cluster software, and they weighed different events so that if the temperature in the server room was getting a bit high and the server was acting a little bit funky and responses were a little bit too long, then all of that would be like, okay, the air conditioning has broken and let's switch to another data center. And that they actually saved them from getting into trouble a very hot summer day. So it's there's a lot you can do to try to anticipate and handle events in a system. That also adds a bunch of complexity, so it can be a little bit difficult to configure and set up, but hopefully we made it as easy as it can be. When I talk about a cluster, HA cluster, it's not a huge cluster usually. The Linux HA software supports up to around 32 nodes. We're working on supporting more than that, but it's not one of those, 100,000 machine clusters. That's more high performance computing and so on. In a cluster you have a bunch of nodes. Basically a node is a single machine. It can be a physical machine or it can be a virtual machine. For the HA clusters, normally all of the machines would be in the same location. So you would have maybe two blades in the rack or two computers next to each other. And if you want redundancy over larger distances, there's something called geo-clustering that's kind of a layer on top that you can use, where you can have one cluster in one location and then another cluster in another location, and using the geo-clustering software you can fail between them. But the basic functionality is a small set of machines in roughly the same location with very reliable network connections between them. The cluster manages resources, and basically that's software. It can be pretty much anything, and there's a set of rules that govern how these resources are managed. So when I talk about resources in the cluster, there's mainly three different things that we use. So first of all, we have the OCF agents, which is kind of custom written scripts that manage software that deal with a lot of the issues that you have when clustering. So they're kind of custom written for that scenario. So I would say if there is an OCF agent written for the application that you want to run in the cluster, then you probably want to use that rather than using the systemd service unit. But you can use those as well. The systemd service units works pretty well in general because the way systemd is structured, it automatically monitors the services, so you get at least the basic level of monitoring that it hasn't crashed and so on. The LSP scripts usually need a little bit of massaging to work well in the cluster environment, mainly because they don't provide any kind of monitoring most of the time. So that's something to keep in mind. Between resources in the cluster, you can have constraints, which are basically rules governing how the resources are started or distributed in the cluster. And the basic set of constraints is co-location constraints, saying that this resource should preferably be located with this other resource, or has to be located with this other resource. So these two things would run on the same machine. Or you can have negative constraints using scores, so you can say that these two resources should never run on the same machine. The ordering constraint says in which order a resource should start or stop. So I think intuitively you would think of these two as related, that if resource 1 depends on resource 2, you would think that, okay, so first we start resource 1, then we start resource 2, and they both start on the same node. But it gives you a little bit more flexibility to think of these concepts separately. So you can either decide that these two resources have to run on the same machine because they use some system resource that they both depend on, or they have to start in a certain order, but it doesn't really matter which machine they start on. So, and then the final constraint is a location constraint, where you can say that this resource can only start on these certain nodes, or it has to start on these nodes, or it should never start on a certain node. And the way you control the preference is using a score. That's basically a numeric value that doesn't have any particular meaning in itself, other than that positive or negative infinity means it really has to apply. So it forces you the constraint, so it's a hard constraint. Any other score kind of depends on the other scores you assign to other things, so it's a relative measure, so there's no generic way of stating that. And then you can also, to complicate things, have something called rule expressions, which are basically saying when a certain rule applies. So it can be that a certain rule only applies on a given set of nodes, or it only applies a certain times of day, so you can have different rules for the peak hours, or different rules for winter compared to summer, or whatever you want to do. So it's a very flexible system. And if you want to know more about HA and the cluster software in general, you can go to clusterlabs.org. It's the general website for the whole project, shared by all the individual pieces. I haven't really talked about what those pieces are or a lot of the things that they do, but in short, if you want to try this out, you can do it on OpenSUSE by installing HA cluster bootstrap and running HA cluster init on a fresh OpenSUSE machine, and you will have a basic one-node cluster that you can play with. And that's it for my introduction to clustering. And if you want to know more, the best thing you can do is travel back in time to yesterday, because Richard delivered a talk talking about exactly this in more detail. So there may be a time machine on the internet that you can use to see that. Yeah. All right. So Hawk is basically a user interface for the cluster software. It's a web UI written in Ruby on Rails. It runs on the cluster nodes themselves, so it's installed as a package on the cluster nodes, and you access it by accessing a certain port on the cluster node. It provides a dashboard or status view that you can use kind of as a run it on a monitor in your admin room and see if everything's going well. But it can also be used to configure clusters and administrate clusters, so you can basically set up a complete cluster using just the web interface. The source code and the development happens at this URL on GitHub under the Cluster Labs banner, and contributors are more than welcome. So I didn't write Hawk originally. The author of Hawk looks like this. That's Tim. He lives in Tasmania. He's also a pig farmer, so he's busy. And right now he looks like this because he's working on SUSE storage and Ceph. So while he's doing that, I'm taking over Hawk, and basically we're gonna redo it completely. So. So to just give you a taste of where Hawk is going, I'm going to show you the dashboard view, what it looks like today and what it's going to look like, or what the development version looks like right now. So this is kind of the first view you see of Hawk when you start it. So you can see, I don't know if you can read the text, but we have 4 nodes running 2 groups of resources distributed by different rules. Everything is green, so that's good. There's no warnings. It's not the most beautiful interface in the world. It's a little bit outdated, but it works. It works really well. There's also the multi-cluster dashboard, which shows you the state of multiple clusters, so you can connect in the geo-cluster scenario, or just if you have multiple clusters but they're totally unrelated, but you want to monitor all of them from a single point. You can use the multi-cluster dashboard to see the status of all your clusters and see if anything's going on any of them. So this is basically what it looks like today, and this is the version that's in OpenSUSE 13.2 and also in SLE. So this is kind of the mock-up of what it's going to be. It's still in development. It's not finished. I think the most important feature is that we now have a happy face that shows you that everything is good. So as long as you see the happy face, then... Sorry? Yeah, that's the big debate right now, is what kind of face to show when things are going wrong. Yes. Is there an API? No, there's no API. That's something I would like to have. Yeah, I'm thinking about how to do that the best way. But right now it's very focused on just being the user interface, and we haven't really in the previous version there's no API you can use. In the next version, maybe. We'll see. Yeah, but that's good. If you have a use case for it, like this is what I would use it for. Yeah.
And the other one is integrating into a bigger management environment, like SUSE Manager or stuff.
Yeah, that's great. I have nothing against that. We just have to see how much work it would be if I can finish it in a reasonable amount of time. But I too prefer to have a cleaner API to work against in the user interface. So I think that's definitely something that's going to happen. I don't have a date when it's going to be done, but yeah. So you can also use Hawk to configure resources. I'm just going to show like a little example of creating a order constraint. This is also kind of a mock-up of the new interface, but it would look something like this. You would, select the resources you want. You can add options and any kind of rule expressions that you want on top of that. There's also something we call wizards or configuration scripts, which gives you a ready-made scenario that you can use to configure the cluster. So basically the idea is that you install the cluster software and you immediately go to the web interface and you pick one of these and you get a basic configuration. At the moment, in the old version and the way it's structured right now, the wizards only perform the cluster setup. So it's not a configuration management solution. It doesn't actually configure the nodes for you or install packages and so on. So if you want to set up a SQL database, you basically have to configure the SQL database beforehand and then bring it into the cluster using the wizard. This is something that I'm working on improving. We already have the backend for this, and we have an experimental wizard, so to speak, which is the NFS server wizard. So the NFS server wizard can actually configure the NFS setup for you and the mount points and so on. So, yep. Yeah. No, I started out using Ansible, but Ansible basically SSHs as well. So yeah, I might go back to that. Yep. Oh yeah. Yeah. So the question is if I'm using Ansible or Chef or Puppet or something like this in the backend, and the answer is no. It's basically SSHing to all of the machines and running the script directly. But I didn't want to use Chef or Puppet or one of these because I didn't want to interfere too much with the system administration of the cluster nodes directly. So, I mean, the idea is that this is something that runs on machines that are important, that you have a system administrator that cares a lot about the software that runs there. And that system administrator probably has some preference for the configuration management setup that they want to use. So I would rather not restrict that in any way. In the same way, Hawk doesn't use Apache or something like this as a web server, because I don't want to risk interfering with someone actually running Apache as a cluster resource. So, yeah. The next nice feature that you get in Hawk is the simulator. This may be the most beautiful part of the old interface. It looks like this, with a lovely yellow background. But it is actually a really cool feature. So what it gives you is a way to see what would happen if something happened in the cluster, very visually. So you can, after configuring your resources, you can actually run a bunch of scenarios in the simulator and get a sense of if the constraints that you set actually are the constraints that you want. So you can see the interpretation of the cluster software of these constraints. So you can see if there's any weird interaction between different rules or anything you hadn't anticipated. So as an example, here you can see we have 2 nodes, and on one of the nodes we have 3 resources, which is basically a web server and a virtual IP running on that node. And what I'm going to do is I'm going to inject a state change, which is saying that that node goes offline. And then if I run that simulation, you can see that the web server resources have moved to the other node, and the fencing resource, which is something I didn't mention in the HA intro, but fencing is basically a mechanism for ensuring that a node that is misbehaving is actually properly dead and is not going to come back and start running resources on its own, like interfering with the shared disk or something like that. So the fencing mechanism doesn't have to fail over, so that one is stopped, but the other resources are moved to the first node. And you can also get even more details on exactly what the decision was, like which rules applied and so on, using the links to the CIB and the graph. So the CIB is basically an XML document that describes the configuration and state of the cluster. Hawk will give you a friendlier interface than just plain XML, but you can look at the cluster configuration before and after the transition to see what happened. So yeah, I think this is a really cool feature. So something that's kind of related to this is the History Explorer. So one of the problems with cluster software is that the whole idea is that it's supposed to take care of things when you're not looking. So you can leave machines running, and if something suddenly happens, hopefully the cluster software will deal with it, and your thing will keep going. But you still want to know that something happened, and you want to find out what happened. I mean, if you have a 2-node cluster and 1 node dies, you're basically running without a backup and without high availability at that point. So you don't want the cluster to just totally mask it and just pretend that everything's fine. You want to be able to figure out exactly what went wrong, when it went wrong, and see what all of the state of all of the nodes was. And this is what the History Explorer helps you do. So to demonstrate this, I have a basic cluster configuration where I'm running HA proxy, which is a load balancer, on 1 node, and then I'm running web servers on 2 other nodes. And the 2 web servers are constrained to never run on the same machine. And the proxy server prefers to run on the first node. So by default, the cluster software will try to spread resources evenly across the cluster to load balance. So in a 3-node cluster, this usually ends up meaning that HA proxy runs on the first node, one web server runs on the second node, and the final web server runs on the third node. If one machine goes down, one of the web servers will move to the proxy node, or the proxy will move to one of the web server nodes. And if another machine goes down, only one web server will be running, and the same node will run the proxy and that web server. So it handles failure down to from 3 to 1 node, hopefully. So what will happen if I do this? This is just a demonstration, but basically what I do is I kill the proxy, and I'm going to see what happens, and what can I see in the logs about this. And if you don't use the History Explorer, just figuring out when it happened can be difficult enough. But then also figuring out which node was the resource running on, what was the failure, which logs are relevant to that particular transition, and so on. All of that can be kind of tricky. The cluster software logs quite a lot of information, and you have to look through it to find the relevant information. And with the History Explorer, this gets really easy, and it's something you can do almost immediately as a failure occurs. So yeah, let's have a look. So here is my test setup as I described it. The first thing that happens is that you get a little yellow bar saying that something is happening and the cluster is figuring out what to do about it and how to do it, how to recover to a good state. Once that had happened, everything goes back to being green. So this is maybe one of the weaknesses with the old interface that I would like to fix with the new one, because the old interface, all it does is it puts a little triangle next to the resource that has failed over, and if you're not looking carefully, you may not see that. But the idea is that everything is running well. You know, there was a problem, but it's been dealt with. But you can see that something has happened. There's been an event, and you can look more closely at it. So in this case, we can click on that resource and view details. And we get this screen, which may be a little bit difficult to see. Yeah.
Just thinking with the tempo, would color coding like yellow as, you know, this is the event? I mean, maybe you can also color coding for transitions, but yeah, that would probably be where it's there, it's working, but it's not.
Yeah. So the question is, well, the comment is, maybe you could color code it. And yeah, so in the new interface, what I would like to do is the smiley face basically means that everything is good and everything has always been good, and you know, there's nothing weird ever happen. And if any resource at any point had a failure, then you wouldn't get that green happy face. You would get a little bit more cautious, maybe yellow, maybe orange, depending on just how serious. And also you would get the flash at the top of the interface saying more details, that this is the failure that has occurred. So the idea is to make it more obvious that something has happened, even if everything is running right now. So yeah, I don't know if you can read exactly what this says, but it basically says that there's been one failure. It shows you the state of the failure counts, or what's happened on each node. So you can see that the failure occurred on node 1. And you can also see the actions that the cluster took on each node. So you can see that the cluster on node 1 had a monitor call which failed with return code 7. So at that point you would have to look at the resource agent to see exactly what that meant, or look in the logs. But then it ran the start command to restart a resource on the same node, and then when it monitored the resource again, everything was fine. So at this point everything is good. And you can also see that it's also monitored all the other nodes for this resource. This is to make sure that the reason the resource failed on the first node wasn't that it was actually running on some other node, even though the cluster hadn't told it to. So in a way, the cluster software is like an extra sysadmin. You know, it's keeping track of what's running on the machine and taking action if something changes. If an actual sysadmin shows up and starts changing things, that can really cause problems. And that's actually maybe one of the main areas of why things go wrong, is that someone accidentally restarts a resource or stops a resource, and in this way we can see that the cluster can actually report that, actually the resource failed on node 1 because it was running on node 2. You can also see the actions as quoted from the log file. So this is actually taken directly from the logs on node 1, showing the actions that were taken. Once you've determined that, okay, I've seen the error, and you want to get rid of the little triangle, or you want to get back to the green happy face, you would clean up the resource and you would forget about the previous failure. So this is, once you've decided that, okay, everything is okay now, I want to go back to green so I can see when it turns yellow again the next time, you will run this. So this is the History Explorer interface. So there's basically two ways of using this. Either you give it a time span over which you want to examine the cluster events. So you'd say what happened in the cluster from this time to this other time. And by default, Hawk defaults to showing you what happened during the last 24 hours. I think that's maybe a little bit too much as a default, because it actually has to go through all the logs for all those 24 hours, so it takes a little bit more time. And usually, or hopefully, you would discover something went wrong maybe within the hour or maybe a few hours. So we'll see, maybe I'll change that. But you can also save the state of a cluster over a certain time period as a tarball, which is something that we use when developing, and QA uses to give us more information of, if something happened, what happened. We can collect that and send it to me, and I can look at it. Yes? Yeah. Yeah. So the suggestion is to show a Dropbox giving you choices like the last 24 hours or 1 hour and so on. And yeah, I'm definitely going to add that. But in this case, we're looking at a little bit shorter time span because I just wanted to demonstrate this. So I'm basically looking at the last 5 minutes of the cluster in this case. Hawk will go out and collect data from all of the cluster nodes, since some of the log information that you may be interested in may only have been logged on one particular machine. So it has to go and look at that machine. To do this, it needs kind of a special configuration for SSH access. So this is, one of the limitations of Hawk, that you kind of have to configure it in a particular way to be able to use these features. But if you've configured it so that Hawk can access the other nodes and get the information from them, then that's what it does at this point. And once it finishes collecting the data, it shows you an interface like this. And basically this is a timeline from the start of the time frame you gave it to the end of it, showing you each transition in the cluster. That is, every time the cluster resource manager decided to reallocate or modify the settings of resources. You can get the PE input file, or there's also PE warning and the PE error files that are basically the state of the what is called the policy engine, but the resource manager of its model of the cluster. So you can get, for each transition, you can get the information about what does the cluster look like, and how has the model changed, and what will the cluster do about it. So if we look at so this is basically the information from the p-engine output. So here we can see that we have a failure in the proxy group, which is that the HA proxy failed, which is not surprising because I killed it. And you can also get a transition summary that says processing failed, monitor for proxy on node 1, not running. So you can actually get quite a bit of information already, and even at this point you've saved quite a bit of looking around in the logs for finding that particular line that says that, the monitor action returned return code 7. You can actually get just that information that you're interested in. And then you can also see what changes is the cluster going to do about it. And what you can see is it's going to stop the resource. This is to make sure that it really did fail. It's not just a glitch in the monitor action. So in case the monitor action is kind of buggy and sometimes says that the resource is not running even if it is, well, this is going to make sure that it really is not running. So that's a reason to make sure that your monitoring actions actually work and are reliable, because if the monitoring is not reliable or the timeouts are a little bit too short, you can actually provoke failures in the cluster, since the cluster software will decide that, it's not running, better make sure and stop it even though it was running. So, but in this case, it's just going to restart the same resource on the same machine and then look at it again and see if it's fine. By default, HA proxy or the HA software will restart a failed resource up to 3 times on the same machine before deciding it's time to move it to another machine. This is something you can configure if you want it to fail over immediately or after a longer period and so on. Yeah, this is just more of that. And this is, yeah, just saying the same thing really. You can see the actions taken at that point by the cluster. You can also get a graphical view or a graph view of the transition calculation by the cluster software. So here you can see that the first thing it's going to do is it's going to stop the proxy resource and hopefully reach a point where it's stopped and then restart it. And in parallel, it's going to start looking that it's running and also run the monitor. So you can see sometimes the cluster will do multiple actions in parallel, and this is a way to see that is kind of difficult to see from the log, since the log is a linear format. So you will see like, first it does this, then it does that, but you can't really tell that it actually decided that it's going to do all of these things at once. So this is actually quite valuable. And then the final view, which is perhaps the one in most need of updating visually, is the diff view. But it's actually one of the most useful ones, because here you can really see the whole timeline of what happened and what the cluster did about it. So the first thing that happens here, you can see that it was in a state where the HA proxy was started on node 1, and then it went to failed, and we can see the failed action appear as well. If we go to the next transition, we can then see that it goes from being failed to being stopped. It means that the cluster software now has run the stop action and ensured that the HA proxy really is not running. And then the next thing that we can see here is that the failed action disappears from the logs. And HA proxy is now started again. So you get the whole kind of timeline of events in a pretty nice format that you can scroll through and see, okay, so this is exactly what happened, this is when it happened. And yeah, so as a summary, if you're using Linux HA and pacemaker and so on, and you're not using Hawk, you're missing out. I think personally, for configuring, I still use the command line. I think that's a nicer way to do that stuff. But for the simulation and the history viewer, I think Hawk is really nice and a really useful tool. And yeah, the new version is going to be even more awesome. And I should say that it's not just me working on the new version, it's also Thomas Berger at SUSE and a guy called Manuele who is designing all the graphical niceties. So it actually looks good and not like programmer art, which is what it would be otherwise. And yeah, that's me. Any questions? Yeah, I love this one. Yeah. All right. Okay, no questions. Then if you want to talk to me afterwards, I'm around. So, yep. Yeah. So right now, the graph is actually generated kind of on the server side. So it's just, in the interface, it's actually just a PNG from the server side. So it's very limited what I can do with it. So in the new interface, I'm just going to send it to the front end and let the front end render it as SVG. And then I can attach all kinds of information, showing it actually, so you can click from one to the next, so you can see the transition as it goes through. And the same thing with the diff view is actually also rendered server side as an image, which is crazy. But so I'm gonna do that client side as well. So yeah, it's gonna be way more usable in that sense. I mean, this all works. You can actually use it, but it takes a little bit of getting used to. And yeah. All right. Thanks.